Hello everyone, welcome to our channel Artezmia. This is our first video about electronics. We will make a laser tripwire alarm. It is nothing really original, but when I needed one, I searched YouTube and the internet in general, and I could not find anything easily replicable that could be used in working conditions. Pretty much everything I found stopped at the breadboard stage, which is not really practical to use in a working environment. While I had some knowledge about electronics at the particle level when I studied physics many years ago, I had no practical experience whatsoever, and I had never even used a soldering iron before. I assume very little knowledge from my viewers, and I bought the components on AliExpress or Banggood, either one, and I used recycled items that I could find in my house. There's a link below to my website where you can see the pictures and the circuits that I used in this video. The circuit, you will need an old CD, you'll need a little piece of mirror. It can be a piece of broken mirror that I found one in my house, and you will need a power adapter, 12 volts, a jack, a 555 timer integrated circuit, a siren, a 12 volt one, they are louder than the 5 volts one, a light dependent resistor or LDR, a 1 megohm resistor, a 10k resistor, a 470 ohm resistor, a LED any color, a 10 nanofarad ceramic capacitor, a 100 microfarad 25 volts capacitor, electrolytic, a laser module, a buck converter 12 volts to 5 volts to power the module. I soldered head pins to the buck converter to make it easier to use. The old CD, I cut it in a rectangular shape, 98 by 60 millimeters, using a rotary tool. And you need to peel off the film that covers the CD. Cut a piece of paper the same size and glue it with a glue stick to the acrylic. Mark the places of the components and where to drill the holes. And drill the holes with a small rotary tool like a Dremel motor tool. I used a 0.8 millimeter bit. For the 555, it's better to punch the holes through the paper with the IC before gluing it. It makes it easier to locate properly the places. The LED and the 470 ohm resistor are optional, but in the testing phase you might want to avoid to trigger the siren all the time, and just having a visual aid to see if it works or not is a lot easier. You can certainly remove it after you're done with your circuit. Here's the schematics of the circuit. I did use a breadboard before committing to the CD and solder the components, but the circuit is so simple you can easily skip this step. For the 555, pin 1 goes to ground, pin 4 and 8 to VCC, that is 12 volts, pin 5 to ground through the 10 nanofarad capacitor, pin 3 to the siren, and then to ground. Remember, the siren is polarized. In parallel, I placed the LED and the 470 ohm resistor in series, and then to ground. Pin 6 and 7 shorted, and then you solder a wire that will go in the middle of the 1 megohm resistor connected to VCC and the 100 microfarad capacitor connected to ground. Remember, the electrolytic capacitors are polarized. You have a plus side and a minus side, so the minus side of the capacitor will go to ground. Pin 2, solder a wire that will go between the LDR connected to VCC, LDRs are not polarized, and the 10k resistor connected to ground. That's it for the 555. You take a 12 volts wire to the positive input of the back converter and another one to ground. On the output, positive goes to the positive pin of the laser module and negative to the negative pin of the laser module. Here's a picture of the circuit, photograph. Top side. The LDR sticks out. I will want to be able to move it to get to focus the reflection of the laser on the piece of mirror. Here is a picture of the bottom side of my board. Plus and minus are marked for the power supply and the buck converter, as well as E for input and L for output of the converter. I left two wires out on the upside of the board for the siren. Remember, the siren is polarized. The siren will be soldered at the last minute. The values of the resistor and capacitor for pin 6 out of the 555 can be modified according to the time you need the siren to sound when the system is triggered. The rule is T in seconds equals 1.1 times R times C, where R is the value of the resistor in ohms and C is the value of the capacitor in farads. For my particular setup with 1 mega ohm and 100 microfarads, the time will be 110 seconds. That is 1 minute and 50 seconds. You can play around with the values of R and C, but remember that the resistors and capacitors come in standardized values. So if you specify the time, you may or may not find the appropriate values for R and C, and you may have to adjust the time value. Here I show the alarm being triggered. It is played on my desk and the siren is held in place with crocodile clips. I will make a box for the board with 3 holes, one for the laser beam, one for the LDR, and one for power. As I was building this circuit, many ideas for improvements came to my mind, and I will make another video in the future with the improved alarm. Thank you for listening, and if this video was of any value to you, please hit the like button and subscribe. There will be more videos about electronics in general, and as I plan to do a whole alarm system for my house.